Okay, I don't know if you can see all of this stuff or not, but use the given values to evaluate all of the trig functions. The two given values, sine is root 3 over 2, cosine is negative 1/2. Those are clues into what quadrant the trig function is in. Now, remember I gave you this little grid of the 4 quadrants. Remember they're quadrants 1, 2, 3, and 4. And I gave you a code for remembering what functions are positive in appropriate quadrants. And this was the thing, a silly trig code, meaning all functions are positive in the first quadrant, and the sine and its partner function cosecant are positive in the second quadrant, the tangent and the cotangent, and the cosine and the secant are positive in the other quadrant, in the fourth quadrant. So that's where the trig functions are positive. So based on this, we're going to put checks in our grid, and one of the parts of the grid will have 2 checks, and that's going to be the part of the grid that we draw our triangle in to figure all the trig functions. Sine is positive. Where is sine positive? First quadrant and second quadrant. Cosine is negative. Where? Well, cosine's positive first and fourth, so that means it's negative in the second and the third. Now, one of the quadrants has 2 checks. Second quadrant. So I draw my triangle in the second quadrant. It's a right triangle, and the theta in question is right there. So the sine of that theta is root 3 over 2, opposite over hypotenuse. So this is root 3, and this is 2. And when you're doing these triangles, remember that the hypotenuse is always positive. So if you're not sure where the negative sign goes, I usually put it on the top of the fraction. So this was really cosine x equals negative 1/2, and I always put the negative on the top, so negative 1 over 2. So the cosine is negative 1 over 2. Now I have the triangle so that I can get all the trig functions. Sometimes I test to see if my triangle works based on Pythagorean. So is negative 1 squared plus root 3 squared equal to 2 squared? And indeed it is. 1 plus 3 equals 4. So that is a true statement. So now I can get all the trig functions, the sine of theta, cosine theta, tangent theta, and then the reciprocal functions, cosecant theta, secant theta, and cotangent theta. The sine, root 3 over 2, root 3 over 2. The cosine, negative 1 over 2. The tangent, opposite over adjacent, or root 3 over 1. And then these functions are just the reciprocals, 2 over root 3, 2 over negative 1, 1 over root 3, and of course, usually you don't leave radicals in the bottom, but you know how to rationalize those. So there's the answer to the trig functions for that special triangle. And now I think you should have some luck doing your homework. And based on that, now you also will have some other questions to do. Another type of problem you're going to have to do is using the identities that I have written here. And you'll have something like, you'll have to simplify a trig function. And let me do an example of one like you might have to simplify. You might have something like this. Sine x times cosine squared x minus sine x. And the directions are simplify. And basically to simplify, you want to get the problem so that instead of 2 parts, there's only 1 part. Or if it has fractions, get it so that it's not a fraction. Or get everything in terms of the same trig function. So notice this uses both sine and cosine. So I either need to get it in terms of all sine or all cosine. So the first step in that is seeing what you can do in terms of simplify. I noticed that both parts have the sine x, so I could factor that out. Basic algebra skills. Sine x times cosine squared x minus 1. There, I've simplified that a little bit, or I factored it. Now, is there a substitution I can use for cosine squared minus 1 so that I can get the whole thing in terms of sine x? And this one of the Pythagorean identities I can use. I know that sine squared plus cosine squared equals 1, so I could rearrange that. Sine squared plus cosine squared x equals 1. Let's solve that for cosine squared so I can do a replacement. So, cosine squared x equals 1 minus sine squared x. So there is a substitution. I can replace that for cosine squared x. Watch what happens when I do. So the Pythagorean identities, this identity can be written 3 different ways. I could have sine squared equals 1 minus cosine squared equals 1 minus sine squared, and then I have what I started with. So I'm going to replace cosine squared x with 1 minus sine squared x. Watch what happens. Sine x times 1 minus sine squared x minus 1. All right, now if I simplify this, what's 1 minus 1? 0. So now I have sine x times minus sine squared x. You with me so far? Now, if I multiply this out, I get negative sine third x, right? Because positive times negative is negative, and sine times sine squared is sine third. And there I have a simplified version of what I started with, all in terms of one of the trig identity functions. Instead of having sine and cosine, now I have it all in sine. I could have also put it all in terms of cosine if I wanted. Whatever works for you or seems easier using substitutions. All right, that's it. Good luck on the homework.